CPU is the heart component of your computer. In this video, we'll be covering some important specifications of the CPU. You don't have to understand all of them to make a purchase, but they are good to know for a PC enthusiast. Starting with the clock speed. A processor's clock speed, also called frequency, refers to the number of cycles performed every second. The higher the clock speed, the faster that specific CPU core. However, this doesn't mean that two processors with the same clock speed would have the same performance. A modern processor usually has a base clock and a max turbo speed. The base clock of a CPU is the frequency it can maintain when all cores are on heavy load. While the max turbo speed allows certain CPUs to operate above their typical frequencies for a performance boost. A manual way to increase the clock speed of a CPU is by overclocking. Given sufficient cooling and power delivery, some CPUs can be overclocked above their typical clock speed. Not all CPUs support overclocking, though. All AMD Ryzen processors support overclocking, and only Intel Core processor models that end with a K or X can be overclocked. Moving on to cores. A core is essentially a microprocessor within the CPU, and most CPUs today support multiple. The more cores a processor has, the faster it can handle multiple processes, which is important for multitasking or for heavy workloads that can take advantage of multiple cores. To improve multitasking, modern CPUs also support multi-threading, a technology that enables a single core to simulate two virtual cores. These virtual cores are often referred to as threads. You can check the workload of each thread using the Windows Task Manager. In the Task Manager, you can also see the L caches of your CPU. Most CPUs have 3 L caches, where they can store data and access it. Because it is built onto the CPU, these L caches are accessed very quickly, making them very efficient for storing data. You might wonder about the differences between L caches, memory, and disk storage, as they all store data. Here's a simple analogy. Imagine the CPU being a workshop worker, and the L caches would be his two hands. The memory would be the desk he is working on, and the disk storage would be his shelf. Notice, large storages are usually slower and less accessible, and vice versa. The same as with the L caches. L1 cache has the smallest storage size but the fastest speed, and the L3 cache has the largest storage size but the slowest speed among the 3 L caches. When building a PC, the TDP of the CPU is another concern. TDP stands for Thermal Design Power in watts, and refers to the power consumption under the maximum theoretical load. Therefore, the power supply must be able to handle the TDP the CPU is rated for, as well as other components in your build. More powerful components generally have a higher TDP and require more powerful cooling. But do keep in mind that TDP is not the only thing to consider when choosing your CPU cooler. A cooler that can handle 200 watts of TDP on an Intel 11th Gen processor might not be able to cool an AMD Ryzen 5000 series processor at the same TDP. CPUs with improved fabrication node tends to have higher transistor density and therefore higher heat density, making the CPU harder to cool even with the same TDP. Clock speed, core count, multi-threading, L caches, and TDP. We went over these features of the CPU quite quickly. For more detailed information, check out this article on binarytides.com by Silver Moon. Links in the description. Lastly, thank you for watching this video, and see you in the next one.